Hello, and welcome to another Appfarm Developer Forum webinar. In this webinar, we're going to discuss services. Services are extremely useful for handling long or heavy processing tasks, which maybe take a long time to run, and which don't need user interaction while they run. Services can also act as API endpoints, which means that external tools and systems can interact with the Appfarm system. In part 1 of the webinar, we'll discuss what services are and how they work in the context of Appfarm. And then in part 2 of the webinar, we will set up and debug a service using some example tasks. And we will see a bit more about the do's and don'ts while setting up and using a service. So let's get started. What are services and how do they work? Services are essentially an app without a UI. They can still interact with data. They can still create objects, update objects, read objects, and delete objects, set selection, all the action nodes that you're used to inside an app. It works in the same way, except that the user isn't shown an interface. You interact with a service using HTTP requests, which we'll discuss more later. On the right here, you see how services are set up in Appfarm Create. You see each service and all of the endpoints which belong to each service. And when you click on a service, this is what it looks like to configure the endpoints. Each service can have its own service variables, just like each app can have its own app variables. And each service can be connected to one or many actions, which work in the same way as an action does in an app. One key difference between services and apps is that services run on Appfarm infrastructure. It runs on the Appfarm servers hosted in the EU, rather than the client's device, which makes them very suitable for some use cases. Services also have some special features and some restrictions due to the fact that they run on Appfarm infrastructure. You gain access to some features, but you lose access to some others. If a service doesn't have any UI, how do you interact with it? How do you control it? Services are called through service endpoints. An endpoint is a URL which you can send HTTP requests to. And when you send an HTTP request to that endpoint, then the action will be run. In the example you can see on the right, you have two get endpoints, a post endpoint and a delete endpoint. Some of these you're maybe used to from other external APIs, and they work in the exact same way with Appfarm services and these endpoints. HTTP requests are the most common way of communicating on the web. It contains a verb, for example, get, post, patch, and also comes with headers and query parameters, and then a body is returned when the action is processed. Because external tools and systems can interact with your services, it's important to consider authentication to ensure that only the people, tools, and systems that you want to interact with your service are the ones that can. This is done through API keys, which are sent as a part of the HTTP request as a bearer token. So, how are services executed? How are you able to call upon these services or interact with them? You can send a web request to call your service, just like any external API that you might be used to already. You can use the run service action node, which allows you to call a service from an app. You can also use DevTools for services, which is a powerful debugging tool, which allows you to call and inspect how the service performs. So, what can services do? What are services useful for? Services are very useful for doing heavy operations, useful for doing long-running tasks where the user doesn't need to stay online while the information is processed. As mentioned, a key use case for services is to allow external tools and systems to interact with the Appfarm system. Creating a service is essentially the same as creating your own API. Services are also very useful for centralizing business logic, which can maybe be used in many different apps. This means that you can call the service from app A, app B, or app C without needing to rewrite the function in many different places. Services can also be run on a schedule. If you have a job which you want to happen once per day or every hour, then you can set up a service and link it to a schedule, which can be controlled using a cron expression. Or maybe you're wondering how services can run in parallel. Services are actually separated just like apps. Each instance of a service runs for itself, and these are separated from each other. A user can't interact with a different instance of the same service, even if it's running at the same time. Runtime resources and service variables are only available to this instance of this service. As you can see from this diagram, there are 3 requests that run potentially at the same time, but they each have just access to their own today, end of day, and their own subscription. Request 2 cannot interact in any way with the data that's available in request 1, and vice versa. All instances share CPU, disk, and memory, however. They all run on the same infrastructure, they all share the same resources. One user doing very heavy operations can affect the performance that other users experience. However, one service crashing or failing will not affect the running of other services, even if they're running the same service or the same endpoint. Services run on Appfarm infrastructure. Instead of running on a user's machine, they run on Appfarm servers. This makes it scalable. In production environments, horizontal scaling is enabled, and all services are run in parallel. But this only goes up to a certain limit. You are limited by the resources of your tier or your subscription. For example, the number of database operations you're allowed to do per second. Services that exceed these limits are evicted to take care of other Appfarm users who are also using this same infrastructure. If you have an instance where a service is failing or not executing as it's meant to, it is useful to be able to debug this service. Swagger is a built-in documentation and service execution page. You can view the responses and the request. Service dev tools is perhaps even more useful. You can run the service manually, or you can trace a specific request that maybe failed back in time, or you can capture a request as it happens to see exactly how it runs live. Postman is a very useful external debugging tool to test how the service runs for external tools and systems. You can create real HTTP requests and send them to your service endpoints, just like an external tool or system would. This is a useful way to verify that keys and authentication work as they should for external users. And as previously mentioned, Service DevTools also comes with the opportunity to do next request and traced request alongside manual execute. Next request allows you to capture a request and see it execute in real time. Traced request allows you to go back in time using a specific trace ID and allows you to see exactly how a service was executed. When maybe something failed or crashed or didn't execute correctly, you can go and see how it executed to go about debugging. So, when it comes to services, what are some best practices and what are some pitfalls to allow you to build the best possible services for your use case? Database connected data sources should be avoided. If you've seen another webinar where we discuss app performance, this was also discussed in greater detail there. Database connected data sources always read data and always evaluate their filters, even if they're not actively being used in the specific endpoint which has been called. As you can see from the diagram, if you have endpoint A and endpoint B, even if you call endpoint B, which only uses a runtime data source, it still populates the database connected data sources, even if they're only in use in endpoint A. All database connected data sources are initialized on service load, even if they're in use or not in use. And this has to happen before the service can start. For runtime data sources or data connectors, this process is almost instant. But database connected data sources need to evaluate all these filters and read all of the data before the service can start, which can make the service slow to start in many instances. Because of this, runtime-only data sources and data connectors are recommended when interacting with or handling data in services. As you can see from the diagram, loading calendars, loading enums, initializing data connectors, and runtime-only data sources, the process of all of these 3 is almost instant, whereas the process of loading these database-connected data sources is what takes the longest time. And all of these steps need to be called before the service can start. So minimizing the processes that need to happen before the service starts will make your service more performant. When using runtime function properties, it is important to think about the performance of these. All JavaScript executed needs to take less than 2 seconds to run. And 2 seconds is quite a long time as far as JavaScript is concerned, but it is useful to know that any JavaScript operation which takes longer than 2 seconds will crash the server. Because of this, you can consider reducing the usage of runtime function properties. Each time the data changes within a data source, these runtime properties are evaluated again, which can cause bad performance in your service. So, let's discuss in greater detail some performance tips for your services. Performance is critical in services. Since they run on Appfarm infrastructure, they can be evicted if they take up too much computing power, which helps protect other users and other services which are running on the same infrastructure. Avoid expensive operations which take a long time to run. Unnecessary for loops, unnecessary persists should be avoided unless they need to be done, because this helps to reduce the resource demands of your service. Take a look at this diagram on the right, which describes every single step which is involved in the persisting of an object. Even though you're only using one action node, you can see that all of these steps need to be executed before the object is actually persisted. If you have a for loop where there's a persist inside each iteration of the for loop, then you're doing all of these steps for every iteration. Consider putting the persist outside of the for loop at the very end, so that you're only doing all of these steps once and persisting once. These steps need to be done regardless of if you're persisting one object or 50, so it's important to consider if you can persist many objects at the same time. Make sure to be considerate when using the run other service action node. It can be useful as services are run in their own runtime instance. However, when you run a service, it's like starting an app. All of the database connected data sources need to be initialized before the service can start. And this has to happen when you use the run service action node as well. If you're calling many sub-services within a specific service, like in the diagram on the right, then this can lead to service eviction. It can even lead to a loop which never ends. So it's important to keep this in mind when using the run other service action node. Errors can happen in services, just like they can happen in apps. It's important to consider how errors should be handled in services, so that they're shown to the user in the right way, or they're communicated back to the external tool or system in the right way. Decide on an exception strategy. What should happen when an exception is thrown? Maybe some errors are fine, and the service can continue to run, and you can simply create and persist an object in an error log data source, which you can look back on later. But maybe not all errors are okay, and maybe instead you can use the throw exception action node, which communicates the fail back to the user. A custom logging process is very useful when looking back at errors that have happened in the past. On the right-hand side, you can see an example of an event log object class and some event log enums, which can be used together to create an event log object. Every time a user experiences an error or something goes wrong in a service, you can create an object in this object class and persist it. You can read more about custom logging using the QR code on screen, which takes you to the Appfarm documentation. Maybe some errors are critical. In this case, you should send alarms via email, Slack, or even a text message, so that the people responsible are aware as soon as a critical error occurs and they can act upon it immediately. And that brings us to the end of part 1. Now in part 2, we'll take a deep dive into Appfarm Create itself, and we'll set up a service together using some example tasks. So now that we've discussed services and how they work in Appfarm, we're now going to dive into some real-life use cases and how they might be solved using services in Appfarm. In part 2, we've been given a list of tasks that we're going to work through. So I'm going to go through these tasks one by one and then show how they might be set up in Appfarm Create. This is the service that we're going to build upon in Appfarm Create. You can see as of right now it's completely empty and has no endpoints, but by the end we will have a few different endpoints which do a few different things, which will work together to solve the use cases that we've been given. So to begin, task 1. We want an API that can retrieve all taxi companies. Let's start by making a new service endpoint and calling it taxi companies get. And now, to return all taxi companies, we can simply add a new data source, taxi company, read all objects, and then return the data source here in response data. Task solved. So we can check this box, task complete. Sure, It works. But is this really the best way of doing it? Remember what we discussed earlier about database-connected data sources and services, and how they lead to bad service performance. Using the principles we've discussed, it's better to instead make this data source runtime only with cardinality many. And now instead, we combined this service up towards an action. We can call it taxi companies get. Now I can read to this runtime only data source, filter ID has value. And this in principle does exact same thing as read all objects, except it's much more performant. The filter ID has value will return every single object in this data source. Let's change the name to taxis companies temp. And now we will return the temp runtime only data source instead of a database connected data source, which is a much better and more performant way of performing this task. Now that we're reading all objects to a runtime only data source instead of a database connected data source, this is a much better and more performant solution to this task. So now we can check this task off now. Now our next task is to create an endpoint that can retrieve taxi trips, which is many objects. So this is important to think about while setting up this endpoint. You can make a new service endpoint called taxi trips get and connect it to an action called taxi trips get. Because this object class has many objects, we need to consider what is a performant way of returning these objects. We don't want to return every single object because this is hundreds and thousands of objects. So instead, we can implement a sort of pagination approach. With a pagination approach, we need query parameters, which are limit and skip, to say how many objects should be returned and how many objects should we skip before we return these objects. So let's create two service variables called taxi trip limit integer and taxi trip skip integer. And now we can create some query parameters, limit and skip, which we can bind to these service variables. Skip bound to taxi trip skip. So now when we call this endpoint, we have two query parameters, limit and skip, which will affect the results that the user gets back. To ensure that this endpoint is used in the correct way, we can add some input validation. We can make these fields required of data type integer, minimum value 0, maximum value 1,000. Now the endpoint can return a maximum of 1,000 objects, even though the object class in question has hundreds of thousands of objects. This helps to keep the endpoint as performant as possible. We can also add validation to skip, that it's required, that it's an integer, minimum value 0. So now that we've set this up, now we can make a new data source to taxi trip, runtime only, as we remember, taxi trips temp. And now in our get taxi trips action, we can read to taxi trips temp. And we can data bind skip and limit from the query parameters. We're not doing any extra filtering, so we want to return all objects that match the skip and limit parameters sent in when the endpoint is called. So now that we have an action that reads objects to taxi trips, now we can return the data source, taxi trips temp. This will return this data source in JSON format back to the system that called it. So now we have an endpoint that can return taxi trips, and this solves this task. So now we can check the task off as completed. Some users are spamming the TaxiTrip API, which makes it unstable for our other users. Maybe it's possible to add some restrictions to this endpoint. Under the endpoint, you have options here at the bottom called rate limiter. If we turn this on, we get the option to set rate limit points and rate limit window. One request to the endpoint takes up 1 point. So we can say that there is a maximum of 2 rate limit points every 20 seconds. This means that every 20-second window, a further 2 users will be able to call this endpoint. But if a third user calls this endpoint before the rate limit window has refreshed the rate limit points, then they will get back in error 429, too many requests. Using these rate limiter options is a great way of keeping your service performant and ensuring that it works as expected for all users without any lag or performance issues. So now we can check this task off is done as well. Our next task is to create an endpoint which can register taxi companies in the solution. So let's take a look. We can create a new endpoint within the same service. Let's call it taxi companies post. We can bind it to an action, taxi companies post. Because we've already used taxi companies temp for another endpoint, we can use this data source for the taxi companies post endpoint as well as the taxi companies get endpoint. Remember that each instance of each endpoint runs on its own, so there's no overwriting of data to worry about. We can change the method to post, and then in body data, we can map directly to taxi companies temp. And this allows us to map each field directly to the name of the field in the JSON string. For example, company name, we map to name, and source vendor ID, we map to vendor ID. This will create one object in taxi companies temp for each object which is sent in the JSON body. So now in the action, we can simply update all objects with showcase true to show that they came from this endpoint. And now we can persist all objects to the data source. And this will post these taxi companies that the user has sent in to the database. We can also send taxi companies temp back as the response data after the service is finished. So now we have an endpoint that can post a taxi company. So this task is solved. Let's check the task off. As you may have noticed, this previous solution didn't have any validation. What if they tried to post a company with no name or no vendor ID? There was no way of blocking this from happening. There was no validation. So we should add some validation to this solution. In the action, we can try and select a filtered selection in taxi companies temp. If company name has no value or vendor ID has no value, and this will look for any objects in the data source which match this criteria. If the user has posted 100 taxi companies, but one of them doesn't have a name, then there will be one selected object in taxi companies temp. So now we can have an if statement. If taxi companies temp has selected objects, then we can throw an exception. 400 bad request. We can add a message here as well. Enter a name and vendor ID for each taxi company. The execution of the service will stop here after throwing the exception. So if there are any companies which don't have a name or don't have a vendor ID, then the service will never get to here in the case where they are persisted. So now we've added some validation to the endpoint. Let's move on to the next task. You may have noticed that every single endpoint so far has simply been returning the data source once the action has finished running. Now, this can be useful if you're simply using internal debugging tools. But what if you're trying to implement an external system? You need more information from this response body. So what we can do instead is to add some custom response bodies to these endpoints. In Taxi Company's post, we can remove the data source, and instead we can send a custom response body using JavaScript. Here's an example of a custom response body which can be returned. You can see the status, that it ran without problems. You can see the length, how many taxi companies were posted, and then you can see the data source itself. So using this format, we can now simply add in taxi companies temp, all objects. This will return the length of the data source and the data source itself alongside status OK, which is a lot more useful for external systems. For taxi trips get, we can return a similar custom response body. So we can remove this data source and instead use JavaScript. We have the same format, status, length, and data, but this time we are simply binding it to taxi trips temp, all objects. And to be consistent, we can add a custom response body for this endpoint as well. So we can remove the data binding and instead bind a function. Status length data, taxi companies temp. Now that we've given a more useful response body to each of our endpoints, we can mark this task as completed. The next task is about centralizing some critical business logic, which is used to calculate monthly income. As discussed in part 1, services are very useful for centralizing business logic, which is needed across many different apps. Because if you need to update this logic, you then only need to update it in one place, instead of in several different actions across several different apps. So let's make an endpoint which is used to calculate monthly income. So let's make a new endpoint. Taxi trips monthly revenue. Get. We also need the service to know which month the user would like. So let's add a service variable, monthly revenue month, which can be a date time. And now we can pass in the month as a query parameter and data bind it to this service variable. As before, we can add some input validation so that it's required of type datetime. Now we can bind this new endpoint to a new action. Taxi trips monthly revenue get. To be able to collect all taxi trips which are within the month that the user would like, we need to know the start and the end of the month in question. So let's add two new service variables for the month start and the month end. Monthly revenue start of month, which can be of type datetime. And we can do the same for end of month. And now in our action, we can do an update object on service variables. And we can use the value processor to calculate the start and the end of the month which the user has given. So let's bind to month and use the value processor to go to the end of month. We can copy this across to start of month, but instead of end of month, it can do start of month. Now let's create a data source which we can return where the monthly revenue in question will be calculated. So let's add this as a data source now. Taxi trips monthly revenue, runtime only, cardinality 1. We can change the name to temp to indicate that it's runtime only. Now we can create a new object in this data source. We can bind it to the month which the user has given using start of month. Before we're able to calculate the total, we first need to be able to collect all of the taxi trips which are within this month. So let's read all taxi trips which match this criteria. We can read to taxi trips temp, which is a data source that we've already set up for another endpoint. And then we can filter taxi trips dot month. We want the time to be greater than or equal to the start of the month, but less than or equal to the end of the month. So this will return all taxi trips which were run within this month. So now we'll be able to calculate the total in this month using some JavaScript. And this code first filters all taxi trips which have an amount, which is a valid number. And then this part of the function here acts as a for loop, going through every amount which has been filtered down to only include valid amounts, and adding each trip amount to the total, which is then returned here. So now we have generated an object which links the month that the user would like to the total, which is calculated based on the amount that each taxi trip made, and each taxi trip is filtered based on the month. So now we can return the amount in the response body. Return total. Now that we've centralized this business logic, this task is complete. And now there's another use case for services, but it's looking like it will take a long time to process. So this is a use case for async services. So let's take a look at that now. Let's first make an endpoint, async service. Let's bind it to a new action, async service. In this action, we've not been given what we need to do, so let's simply sleep for 15 seconds, 15,000 milliseconds. Now, in the settings, you can run async, no concurrency, and set the job timeout to 30 seconds. Running the service async means that the service will simply respond with a job ID immediately before it's begun to run, and then the service will run in the background. Ticking no concurrency means that there cannot be two instances of this service at the same time, and the job will time out if it takes longer than 30 seconds. So now that we have set up an async service, we can cross this task off as complete. The next task from our client is to set up a scheduled email functionality so that the word is spread about the taxi services to all of the end customers. So let's take a look at how this can be set up in Appfarm. We can again create a new service endpoint, a scheduled email job, and connect it to an action, a scheduled email. Let's use the send email action node. For the sake of demonstration, let's put my own email address in there, but this would normally be data bound to the email address of a customer or customers which you would send this email to. Subject, use our taxi service. And the message, use our taxi service. Always on time and very cheap. Smiley face. It's maybe not the most professional marketing email you've ever seen, but it works. So now that we've made our action and connected it to our endpoint, we now need to connect our service endpoint to a schedule. Schedules are set up here. So let's create a new schedule. Scheduled email job. We can connect it to our service, our email job, and the correct service account. The cron expression determines how often the email is sent and when in the day it is sent. For the sake of demonstration, let's do a cron expression which will send the email every minute. Again, not the best marketing strategy, but it works in this case. We can restrict it to the develop environment and then enable it to test that it works. So now we've successfully set up a schedule. Let's cross this task off. Users have begun reporting that the company sign-up service doesn't work. The company does not show up in the database. Let's go back to our taxi company's post endpoint and see if we can find the issue there. When you have an endpoint that is failing, it's useful to be able to use service dev tools to be able to debug. You can find service dev tools in the top right-hand corner when you're in the services section of Appfarm Create. Let's select our taxi company's post endpoint. Let's create a dummy JSON body to test with. We can just simply create one taxi company name, taxi test debugging, and vendor ID 12345. Now let's execute. We can see that the action runs as expected. We have one taxi company, vendor ID 12345, company name, taxi test debugging, and the whole action runs as expected. Since it's external users who are reporting this issue, it's useful to be able to use Postman to be able to debug it even further. So let's use Postman in this case and see if we can find out what the issue is. Here is what your URL may look like when calling your service. This is simply the hostname for your app, which in this case is the same as here, Appfarm Developer Forum dev.appfarm.app. Then /API/services is always the same. And the last two parts of the URL you can find in services. The readable ID is the last part of your URL, taxi company's post. Then you can find your service alias in settings, alias slug. So you can see in this case, to get to this specific endpoint, you would do ADF webinar / taxi company's post, which is what you can see in the URL here. When communicating from external systems, you also need a bearer token. This can be done in Create as well. Go to Appfarm Create, go to Service Accounts, select the service account which you wish to configure, and then you create an API key. This is used as a bearer token for all external tools and systems which integrate with your service. So now we have our URL, we have our request method, we have our bearer token, and we have a dummy body. So let's send the request and see what happens. Oh no, we got error code 500 back, which means something crashed. We can see from the error message, action node failed error. The persist failed because of insufficient create permissions. The user does not have permissions to create objects in this object class. The object class in question being taxi company. So now with this error message, let's go into Appfarm Create, find this object class, and fix these permission errors. You can fix permissions under permissions and then object classes. You can see for our role, for our service account, they are missing any permissions whatsoever to taxi companies. So let's give them permission to create a taxi company, which is what they need to be able to persist. Now we can go back to Postman and try again. Let's see if changing the permissions fixes this problem. Now we get the status 200 OK. And now we can see our custom response body coming in handy. We can see that we persisted 2 objects, the status was OK, and we get the vendor ID and company name for each of the 2 taxi companies that we persisted. So now we've successfully debugged a permissions issue using Postman and service DevTools. So we can mark this task as done, which was the final task we've been given. So now we have a very satisfied customer. And that brings us to the end of this webinar about services in Appfarm Create. Thank you very much for watching.